Hello and welcome to part 2 of the lecture on logarithms. Today I shall be solving logarithmic equations. These are equations that involve logarithms. But before then, I should quickly remind you of what a logarithm is with two quick examples. Number 1, if you're asked to find the logarithm of 8 to the base of 2, what does it mean? This simply means you should find the power to which 2 must be raised to get 8. And we know already that 2 raised to the power 3 is equal to 2 times 2 times 2, and that is 8. Meaning that if you raise 2 to the power 3, you get 8. Since 2 to the power 3 is 8, it simply means that the logarithm of 8 in base 2 is 3. Again, if you're asked to find the logarithm of say 25 in base 5, what does it mean? It means to what power should 5 be raised to get 25? And again, 5 raised to the power 2 is 5 times 5 equal to 25. 5 squared is 25. So if we raise 5 to the power of 2, we get 25. For that reason, we say that the logarithm of 25 in base 5 is 2. However, we should know also from the last video that the log form of a number and the index form of a number are closely related, in the sense that log 8 base 2 is equal to 8. This logarithm can be converted to an equivalent form which will be in indices. To do that, what do? Log 8 base 2, the base here will take 3 as its power and will send 8 down here. So log 8 base 2 equal to 3 in index form shall be 2 will take 3 up, raised to the power 3 is equal to 8. And of course, 2 to the power 3 is 8 indeed. So what you see here, these two forms are equivalent. Log 8 base 2 equal to 3 is equivalent to 2 to the power 3 equal to 8. This is called the log form, this is called the index form. Similarly here, log 25 base 5 equal to 2. Can we change it to log to index form? The answer again is yes. What do? This base here will carry on 2 as its power, and 25 will drop to the right hand side. So log 25 base 5 equal to 2 in index form is 5 raised to the power 2 equal to 25. And with this, you can change any log form to index form. This will come out to be very useful to us when trying to solve equations that involve logarithm, because most times we want to change the equations from log form to index forms in order to solve. However, I should make this remark that the logarithm of a negative number does not exist. So in the theory of logarithms, we can't find the logarithm of a negative number. Imagine if we were asked to find the logarithm of negative 8 base 2. So that would mean that we should find a number to which 2 must be raised to get negative 8. And of course, that is not possible. So you should also recall your laws of logarithms, because we shall be applying them in solving equations that involve logarithm. However, wherever we need to apply any law, I shall restate the law just to remind you of what the law states. Example 1. Solve the logarithmic equation log x base 6 plus log x minus 5 base 6 equal to 2. So we have log x base 6 plus log x minus 5 in base 6 equal to 2. So we proceed. Having seen this, one law comes to my mind, the first law of logarithm, which was stated in the previous video. And what law is that? The law says that the logarithm of m in base a plus the logarithm of n in base a is equal to the logarithm in base a of m times n. Now this law says that if I have the logarithm of a number in base a in a particular base and it's added to the logarithm of another number in the same base, the law says that I can take the logarithm of the product of m and n in same base. And of course, this law had certain conditions. The first condition is that for this law to be applied like this or directly, the two logs must have same base, base a in this case, Secondly, the coefficient of this log, the number here must be 1 and here also must be 1, like we have in this case. So we now say that the sum of log to the same base is equal to the log of their product. So I see this law directly from here. If I were to compare these two expressions or equations, you see that m is the same thing as x, and n stands for x minus 5, and your base a here is base 6. The log form here has base 6. The log form here also has base 6. The quotient here is 1. Here also is 1. So I can apply this law directly. So that is how you know what law to be applicable. So with this, I can proceed. So by this law, I can write the left-hand side of this equation as the logarithm of x times x minus 5, all to be 6, since the bases are the same, equal to 2, the right-hand side. The next thing I want to now do is, once I've gotten my log on one side as a single term like this, here there were 2 terms of log, the aim was to bring them together and have a single term of my logarithm, which I've succeeded in doing using law 1 of logarithms. The next thing you want to do here is to change this log form to index form. Change from log form to index form. How do you do that? The base here, 6, will take power 2, and we drop this other term to the right, just like we had done earlier when we changed log 8 base 2 equal to 3 to index form. 2 carried 3 as its power, and then 8 was dropped. The same thing we are doing here. So log of x times x minus 5 base 6 equal to 2 in index form. 6 will carry 2 as its power, and then we drop this other term to the right hand side. So if we do that, we will now have 6 raised to the power 2 is equal to x into x minus 5. And what we now have here is the index form of this log form. And it is now easier to solve from the index form. So I have a bracket here, I'll just expand. 6 squared is 36, equal to x times x is x squared, x times negative 5 is negative 5x. I'm already seeing a quadratic expression there. So I'll take this term 36 to the right hand side, and I'll have x squared minus 5x minus 36 equal to 0. So what I have here is a quadratic equation which is to be solved. So I check if I can solve by factorization method. We can factorize as x squared minus 9x plus 4x minus 36 equal to 0. So we have x into x minus 9 plus 4x minus 9 equal to 0. Let's check. X times x is x squared. X times negative 9 is minus 9x. 4 times x is 4x. 4 times minus 9 is minus 36. So that's correct. So we pull just one of these. We have x minus 9 into x plus 4 equal to 0. So this means that x minus 9 is 0, or x plus 4 is 0. So we have x equal to 9 or x equal to negative 4 as our two solutions. But when it comes to logarithms, we must check to be sure that either both of them are solutions, or just one of them is a solution, or neither of them is a solution. So how do we check? Our log was, we're asked to solve the logarithm of x in base 6 plus the logarithm of x minus 5 in base 6, and that was equal to, right hand side was 2. So to check if we are correct, to check which of these solutions is correct, what we do is we pick the first one, x equal to 9, and plug it in here. Where we have x, we put 9. And if we work on the left hand side and we get 2, that means 9 is a solution. We'll do the same thing for x equal to minus 4. So for the first one, x equal to 9. So this becomes log 9 in base 6 plus log in base 6. X is 9. So 9 minus 5 is 4. So how does this become 2? Let's proceed a little bit further. So we can write this as the logarithm, the same law that says we can multiply. So this is log in base 6, 9 times 4. And that gives us log in base 6, 9 times 4 is 36. Now, we can write 36 again as 6 squared. So this is the same thing as the logarithm in base 6 of 6 squared. Now, if you recall again from our laws of logarithm, there's a law that says that the logarithm of m raised to the power n in base a is equal to what? That when the log has a power, we can push the power over here, and that becomes n log m in base a. So we want to apply this law here now. So here we have log, because we have written 36 as 6 squared. So we can now write this as 2 can come this way, and that becomes 2 log 6 in base 6. And if you recall again from our laws of logarithm, we said also that log to the same base is what? Is 1. Log b base b is 1. And of course, in index form, it agrees because b to the power 1 is b. So log to the same base is 1. If we apply that here, you see that 2 log 6 base 6. Now, log 6 base 6 is log in the same base. And this log is nothing but 1. So this is equal to 2 times 1 equal to 2. And that's what we had on the right hand side of our equation. That tells us that x equal to 9 is a correct solution. We have to check also if x equal to negative 4 is a solution as well. So we come back to our problem, and when we have x, we substitute the value of 4. So we have the logarithm of minus 4 base 6 plus the logarithm of in base 6 minus 4 minus 5 is minus 9. So we proceed. Now we know already that the log of a negative number does not exist. However, this is log minus 4 in base 6 plus log minus 9 in base 6. Though the individual logs do not exist, but I have a law of log that allows me to multiply the two logs. So by that law, I can write this as the logarithm in base 6 of negative 4 times negative 9. And that gives us the logarithm in base 6 of minus 4 times minus 9 is 36. And this is the same thing as the logarithm of in base 6 of 6 squared, which is the same thing as 2 log 6 base 6. And log to the same base again is 1. So 2 times 1 is 2. So with this, you see that x equal to minus 4 is equally a solution to our logarithm problem. We shall take another example. Example, solve log 5x minus 4 base 9 equal log 4 in base 3. So I write it out. Log 5x minus 4 in base 9 is equal to log 4 in base 3. Now the first thing I observe in this example is that the logarithms I have been given to me in different bases. The left hand side log is in base 9, while the right hand side log is in base 3. And since they have different bases, it is impossible or difficult, to solve. What we now do is we try to convert, or to leave the two logs in the same base. So we'll make a choice of changing log 9 to log 3, or changing base 3 rather to base 9, or base 9 to base 3, one of them. So I'll change from base 9 to base 3 and change later from base 3 to base 9 and see if we're going to have the same solution. So from our law of logarithms, we have that if we have log, say b in base a, and we wish to change the base of this logarithm to say base c, we write this as log b in our new base c divided by log a in our new base c. And if we do this, we have just changed this log from base a to base c. So we're going to apply this also in our example. So we want to change log in base 9 to a log in base 3. So this will become log 5x minus 4 in our new base, which is base 3, divided by log 9 in our new base, which is base 3, equal to the right hand side is log 4 in base 3. So we proceed from here. Now we can still write this as the logarithm of 5x minus 4 base 3 divided by log in base 3. 9 is 3 squared. What informed me to use this is because I've seen 3 here, and I know that once I put 3 square here, I'll have log to the same base. I've seen ahead, equal to log 4 in base 3. So I have, this becomes log 5x minus 4 in base 3 all over. I've sent 2 to the left. I have 2 log 3 in base 3 equal to log 4 in base 3. And then this gives us log 5x minus 4 in base 3 divided by log to the same base again is 1. So log 3 base 3 is 1. 1 times 2 is 2 equal to log 4 base 3. So I can now write this as log 5x minus 4 in base 3 equal to, I can cross multiply at this point, so 2 will come over to the right hand side, so 2 times equal to 2 times log 4 in base 3. At this point, I now have, left hand side is now in base 3, right hand side is also in base 3. I would love to cancel the logs, but I can't do that because of these 2 here. But there's a law that says I can take the 2 up to this way, so I can write this as log 5x minus 4 in base 3 equal to log 4 in base 3. 2 can come here, 4 squared, because I can still bring 2 down over to the left and it becomes this. So this becomes log 5x minus 4 base 3 equal to log 16 in base 3. The left hand side now is log base 3, right hand side is log base 3. I can choose to cancel the logs, or I take the right hand log to the left hand side. But since both sides have log base 3, I can cancel the logs and just equate the powers. So here I can just equate, or just cancel the log. Let's use that one. Since the logs are now the same, I can just cancel the logs. And I now have 5x minus 4 is equal to 16. And now solve for x. So from here, 5x is equal to 16 plus 4, and that is 20. If you divide both sides by 5, you get that x is equal to 4. Now take note, there are different ways you can, do your algebra, your simplification, other than this. At this point here, you could just choose to leave the 2 here and take this other one to the left. Anyhow you want to do it is fine. But this is how I want to do mine. So at this point, we must check to see if this is truly the solution to the problem. So the question was log 5x minus 4 base 9 equal, okay. So we want to substitute 4 to the left hand side and see if we're going to get the right hand side, which is log 4 in base 3. So let's check. So I have log base 9, x is 4. So 5 times 4 is 20. 20 minus 4 is 16. So I have log 16 in base 9. So I can write this as the log in base 9 of 4 squared, right? Yes. So this becomes 2 comes to the left, that becomes 2 log 4 in base 9. But what I'm looking at is in base 3, right? So can I write this in base 3? Yes, I can. I can write this as 2 log 4, then base 9 becomes 3 squared, because 3 squared is 9. However, there's another rule or another law of logarithm that can help us from here. And the law states that if I have the logarithm of m base a raised to the power b, so if my base, alright, is raised to a certain power, I can write this as 1 over the power of that base, which is b, times the logarithm of m in base a. So here my base is raised to the power b. I can write this as, I can pull the b out and write 1 over b log m base a. So these two things are equivalent. I want to apply this law of logarithm here. So now my base is raised to the power 2. I can write this as So I can take 1 over 2 out, and then what is left there is log 4 in base 3. There's a 2 out here, so the 2 is still there. So that 2 cancel 2, and what I have left is log 4 in base 3, which is what I'm looking for. That tells us that x equal to 4 is indeed the true solution. What I want to now do is to resolve the same problem, but this time we're changing from base 3 to base 9 and see if we have the same solution. So this becomes log 5x minus 4 in base 9 equal to, I want to change to base 9, so that becomes log 4 in my new base, which is 9, divided by log 3 in my new base also, which is 9. So I now have my problem all in base 9, common base, the same base rather. Okay, so what else can I do? I can write this as the log of 5x minus 4 in base 9 equal to the log of 4 in base 9 all over the log of 3. I can change the base again to 3 squared if I want. There's no problem. That becomes the log of 5x minus 4 base 9 equal to the log of 4 in base 9 divided by that same law. Since my base is now having a power, I can pull the power out 1 over 2 and write the log of 3 in base 3. What gave me this idea is because I've already seen log to the same base ahead. That's why I did this. So I have, this becomes the log of 5x minus 4 in base 9 equal to the log of 4 in base 9 divided by log to the same base is 1. So 1 times half is 1 over 2 is half. That becomes the log of 5x minus 4 in base 9 equal to, now log 4 base 9 divided by 1 over 2. So if you divide this, the 2 will come up, and what we have will be 2 log 4 in base 9. So I would like to cancel out the logs here, but this 2 stops me from doing that. Once again, I'll send the 2 up. So I can write this as the log of 5x minus 4 in base 9 equal to the log of 4 squared in base 9. Now I have common logs, so I can now knock off the logarithms. And I have 5x minus 4 equal to 4 squared, and that is what? 16. So I have 5x minus 4 equal to 16. 5x equal to 16 plus 4, and that is 20. Divide both sides by 5, and once again x is equal to 4. So what do we observe? We observe that by changing the base from base 9 to base 3, we got x equal to 4. And now we have changed from base 3 to base 9, we still get x equal to 4. So what does it tell us? It tells us that where we have different bases of our logarithm, it doesn't matter which base we change to. As a matter of fact, even if we choose to change these bases to a different base altogether, for example, instead of base 3 and 9, we'll take it to the common base, which is base 10. It will be the same result. So you can just try that out on your own. Last example. Solve 2 log x base 3 minus log x plus 6 base 3 equal 1. So I write it out. 2 log x in base 3 minus log x plus 6 in base 3 equal to 1. Here, I've seen minus here, so what comes to my mind is the second law of log that states that log m in base a minus log n in base a is equal to log m divided by n all in base a. However, this law is only applied directly like this when the coefficient here is 1 and the number here also is 1. But looking at what I'm given here, I can't apply directly because here I'm having 2 and not 1. So in order to apply the law directly here, I have to take these 2 out of this place. And there's a law that can help me do that, the power law. So using the power law, I can rewrite this as the log of x and then squared in base 3 minus log x plus 6 in base 3 equal to 1. Now the law can be applied since I now have 1 here and 1 here. So I can now pull out and now write log in base 3 and now write x squared divided by x plus 6 all equal to 1. Since I now have a single log, I can now decide to change from log form to indices form. So how do we do that? Remember, this base here will take 1 as its power and will drop whatever is left to the right hand side. If we do that, we're going to have 3 raised to the power 1 equal to x squared divided x plus 6. Since 3 raised to the power 1 is 3, that is just 3 equal to x squared divided by x plus 6. Now we can cross multiply here to find the value of x. So that is 3 into x plus 6 equal to 1 times x squared is x squared. And if we open the bracket here, we have 3 times x is 3x, 3 times 6 is plus 18 equal to x squared. Again, I'm seeing something quadratic. So that becomes x squared, 3x to the right becomes negative 3x, 18 to the right becomes negative 18 equal to 0. So I now have quadratic equation x squared minus 3x minus 18 equal to 0. That should be solved. And once again, I want to apply the method of factorization since I can get factors. So that becomes x squared minus 6x plus 3x minus 18 equal to 0. Minus 6 plus 3 is minus 3. Minus 6 times 3 is minus 18. So we are correct. So now factorize. So in the first bracket, we factorize x. We have x minus 6. Second bracket, we can factorize 3. We have x minus 6 equal to 0. Let us check. X times x is x squared. X times minus 6 is minus 6x. 3 times x is 3x. 3 times minus 6 is minus 18. So we are okay. These two brackets are the same. We pick one. We have x minus 6, x plus 3 equal to 0. So that means we have x minus 6 equal to 0 or x plus 3 equal to 0. So x equal to 6 or x equal to negative 3. So we don't stop there. We must check to see if both of them are solutions or just one of them is the true solution. So for the first one, for x equal to 6, what we had, we were given 2 log x base 3 minus log x plus 6 in base 3. So now put the value of x equal to 6 into this left hand side and see if we can get 1. So when x equal to 6, we have 2 log 6 base 3 minus log, this is in base 3, 6 plus 6 is 12. Okay, I can take these two now up by the power rule. So that becomes log 6 squared base 3 minus log 12 in base 3. So that 6 squared is 36. That becomes the logarithm of 36 in base 3 minus log 12 in base 3. Now I have same base. Here is 1, here is 1, and I have minus in between them. So I can apply the second law. So that becomes the log in base 3 into 36 divided what? 12. 36 divided 12 is 3. So that becomes the log of 3 in base 3. And once again, log to the same base is what? Is 1. So that tells us that x equal to 6 is indeed a good solution or a solution to the given log problem or log equation. So now check if the second one, x equal to minus 3, is also a solution. So we now substitute also minus 3 for x. So that becomes 2 log negative 3 base 3 minus log minus 3 plus 6 is 3. So that is 3 base 3. Very good. So that becomes 2 log minus 3 base 3 minus log 3 in base 3. Now, we should recall that the log of a negative number does not exist. Okay, so if you're not careful, you are quick to just conclude here that minus 3 is not a true solution. But that should not be the case, because by the power law, we can still simplify this further. By the power law, this 2 can go up. And if the 2 goes up, this log becomes the logarithm of minus 3 all squared in base 3 minus log 3 base 3. Of course, this is already 1. If this was like this way, this will become this, is it not? Because the 2 will come to the left. So since it is in this form, the 2 can also go up, to become the power of minus 3. So if that's the case, we can now write this as what? So that this becomes the log in base 3. Minus 3 squared means minus 3 times minus 3. And that is 9. Minus log to the same base is 1. That being the case, we can simplify this further as, so log, we have base 3. 9 can be written as 3 squared, right? Minus 1. So by the power law again, this 2 can come over this way, and that becomes 2 log 3 in base 3 minus 1. And once again, log to the same base is 1. So that is 2 times 1 minus 1. So 2 times 1 is 2 minus 1 is 1. So once again, x equal to minus 3 is also a solution. There's some solutions, there's some people that will solve and they will tell at this point that minus 3 is not a solution. But that is not really correct, because though the log of a negative number does not exist, but by the way this number is, this log is kept, we can take this 2 up and simplify the log even further. So I hope you understood the examples in this video. Please do not fail to leave a comment, like, and subscribe to my channel. Thank you, and bye-bye.